Welcome to the Crazy Hat Chemist. So another video here on electrochemistry. So let's get moving. Bam! So if you're feeling a little bit unbalanced with your electrochemistry problems, we're going to help you out here today. Okay, we're going to balance the electrochemical equation number 12. This is 12 of 12. That is awesome. Okay, here it is. We're going to balance the redox equation below. Here it is. It is the chlorite ion plus MnO2, that's the manganese dioxide, gives you hypochlorite, that's ClO minus 1, and the permanganate ion. Okay, this is in a basic solution, so it's another one of those in basic solution problems. So the first thing that we need to do is assign oxidation numbers for every single element. Remember, the oxygen is a -2, and therefore you're going to have to derive the oxidation number for that chlorine. And that's going to be a +3 based on that 2- charge on the oxygen, that there are 2 of them, and that there's a charge of a -1 on that. With the manganese dioxide, the oxygen is a -2, and there are 2 of them, and therefore there's a 4+ charge on that manganese and that 2- there. On the hypochlorite ion, that ClO minus 1, the oxygen is a -2, there's a net charge of a -1, and therefore there's a +1 charge on that chloride, and a -2 there. And the permanganate ion, that has a -2 charge on the oxygen. There are 4 of them, and there's a net charge of a -1, therefore you're going to derive the charge on the manganese, and that's a +7, and that -2. Now from this, then we're going to decide what 2 elements change in oxidation number. And it is most certainly the chlorine and the manganese. So the chlorine here is a reduction. It's going from a 3+ to a 1+. That's a reduction. That's a decrease in oxidation number. Then the manganese is going from a 4+ to a 7+. That's an increase in oxidation number. That is oxidation. So what we're going to do is we're going to write our 2 half reactions. Here we go. Bam, there's one of them, and that is the chlorite going to the hypochlorite ion, and here is the second half reaction, manganese dioxide going to the manganese permanganate ion. Okay, so for that top reaction here, for the reduction half reaction, we are going to balance the non-oxygen, non-hydrogens first. There's 1 chlorine on the reactant side, 1 chlorine on the product side, that's balanced. Now we're going to go for the oxygens. There are 2 oxygens on the reactant side. There's 1 on the product side. So I need to add an equivalent number of water molecules for every oxygen that I need, and that would be 1 oxygen I need on the product side, so there's 1 water molecule. Now I'm going to balance the hydrogens. There are 2 hydrogens on the product side. I need to add 2 hydrogen ions to the reactant side. Since this reaction is in a basic solution, I'm going to add an equivalent number of hydroxide ions as there are hydrogen ions. Bam, right there. Okay, I am going to add an equivalent number of hydroxide ions to both sides. So I added 2 hydroxides to the reactant side. I'm going to have to add 2 hydroxides to the product side. Bam, done that. Now, I did say that this was in basic solution. Those excess hydroxide ions lets you know it is in a basic solution. Furthermore, on the reactant side, I have a hydroxide and a hydrogen. For every hydroxide and for every hydrogen combination, I'm going to have 1 water. I have 2 hydroxides, 2 hydrogens. I'm going to cross these out. I'm going to get 2 waters. Now I need to balance this for charge. On the reactant side, it's a net charge of -1. On the product side, it's a net charge of -1 plus the 2-, that's a 3- charge. So on the product side, I have a 3- charge. On the reactant side, I have a 1- charge. I need both sides to equal the lower charge, which is the 3- charge. I'm going to have to add electrons to the reactant side and 2 of them so that I have a net charge of 3- on the reactant side, which is equivalent to the 3- charge on the product side. Okay, I am done with that half reaction for the moment. Now I'm going to deal with the oxidation half reaction next. I got 1 manganese, 1 manganese. I'm balancing the non-hydrogens, non-oxygens first. Then the next thing I'm going to do is balance the oxygens. I got 2 oxygens on the reactant side. I got 4 on the product side. I need to add an equivalent number of water molecules for every oxygen that's required. So I'm going to add 2 water molecules to the reactant side. Now I'm going to balance for the hydrogens. So I have 2 times 2, that's 4 hydrogens on the reactant side with that 2 water molecules. I'm going to have to add 2 hydrogen ions to that product side. Since this is in a basic solution, I add an equivalent number of hydroxides as I do hydrogens to that same side. That's why the 4 hydroxides. Since it's in a basic solution, however many hydroxides I add to whatever side, I add an equivalent number to the other side. So I'm going to add 4 hydroxides to the reactant side. I'm also going to combine every hydrogen ion with every hydroxide ion, and that will give me crossing the hydrogens and the hydroxides, crossing them out. And since there are 4 of each, I will have 4 water molecules. Now I need to balance this for charge. On the reactant side, I have a 4 minus charge. On the product side, I have a 1 minus charge. I always go towards the lower of the 2 charges, which is a 4 minus charge. So I'm going to have to add electrons to the product side. How many? 3. So there's that right there. In order for me to finish up this problem, I need to sum up these 2 equations. But in order for me to sum them up, I need to have an equivalent number of electrons on opposite sides. So I'm going to have to multiply the top equation by 3 and the bottom equation by 2. That will give me a total number of electrons on both sides of 6, which will cancel out. And that's our end result. So I'm going to draw this arrow, drop it down, and I'm going to distribute that 3 over everything in the reduction half reaction and distribute the 2 over everything in the oxidation half reaction. So there is my reduction half reaction. Here is my oxidation half reaction. And just as a little reminder, I have kept my division line, that is the arrow, between the reactants and the products in a vertical line, and that way you can separate them out easily. I'm going to draw a line in the sand, and then I'm going to cancel out the electrons. There are 6 electrons on the reactant side, 6 electrons on the product side, and I do know that I can cancel out these and now sum up the equations since the electrons cancel out. That is what we are trying to do, is cancel out the electrons. That is the key to solving these redox balancing equations. Now, what we're going to do is look for similarities that are on the same side or opposite sides of both of these equations. For example, hydroxide ions. There are 8 hydroxide ions on the reactant side, 6 hydroxide ions on the product side. There will be a net of 2 hydroxides on the reactant side in the net balanced equation. Then there's something else that's similar. And the other thing is similar is the water molecules. There's 6 plus 4, that's 10 waters on the reactant side. There's 3 plus 8, that's 11 waters on the product side. There's going to be a net of 1 water molecule on the product side. There are no other similarities, so I'm going to drop everything else down. And that's what I get. So now I need to verify and check. I'm going to check for balancing of mass and balancing for charge. So I'm going to balance the number of oxygens. There's 2 oxygens plus 3 times 2, that's 6. So 6 plus 2, that's 8. Plus 2 times 2, that's 4. So that's a total of 12 oxygens. On the product side, there's 3 plus the 2 times 4, okay, plus the 1, so that's 8 plus 3, okay, plus 1, that's 12 again. So there are 12 oxygens on both the reactant and the product side. The number of hydrogens. There are 2 hydrogens on the reactant side, and there are 2 hydrogens on the product side. The number of chlorines, there are 3 chlorines on the reactant side, 3 chlorines on the product side. Okay, the number of manganese on the reactant side is 2. The number of manganese on the product side is 2. They're balanced. This is balanced for mass. Is it balanced for charge? There are 2 hydroxides, that's a 2 minus charge in total, and there are 3 chlorite ions, that's a 3 minus charge. So that's 2 minus and the 3 minus, that's a 5 minus charge on the reactant side. On the product side, you have 3 times negative 1, that's for the hypochlorite, that's a 3 minus charge, and the permanganate, that's MnO4 minus 1, there's 2 of those. And that's a total of 3 plus 2, that's a 5 minus charge. So this is balanced for mass and for charge. Now I'm going to label it. Okay, the chlorite ion, in fact the chlorine is undergoing reduction, it's the oxidizing agent, and the MnO2, the manganese dioxide, is undergoing oxidation and it's the reducing agent. Okay, that is number 12 of balancing redox equations. Now, we are not done with this unit on electrochemistry. We have many more other types of problems to do, but we need to balance redox equations to do any of the other problems. Okay, this is a sequential, stepwise method here of half cell balancing. And so hopefully that works well for you. I've done general balancing, I've done balancing in acid, and these are balancing in a basic solution. Okay, I am the Crazy Hat Chemist, and of course we can never end this video without a crazy hat. And in this case, I believe it's more like a crazy bell, okay, if you will. So, 1, 2, 3, boom. Okay, it's a diving bell. If you like that video, give me a thumbs up. Please subscribe to my YouTube channel. Pass on my YouTube channel to anybody that's in your chemistry class. Find my website, donate to my website, and get some merchandise, either a sticker or a t-shirt. I'll see you later for next time. Bye for now.